Henry N. Pollack, A World Without Ice. Embark on a fascinating journey through the history and science of Earth's poles in the book, A World Without Ice, by Henry N. Pollack. Discover the differences between the North and South Poles, their importance in regulating Earth's climate, and the consequences of a warmer future devoid of ice. This summary will explore past ice ages, the impact of human activity on climate change, and the importance of adopting efforts towards climate mitigation. Delve into the current and future implications of our rapidly warming planet and understand the urgency to act before it's too late.
Unveiling the Poles Mysteries. In 1768, James Cook embarked on a daunting mission to search for Terra Australis Incognita, urged by ancient Greek arguments of landmass symmetry. Despite their similarities, the South and North Poles starkly differ in location, ice composition, and shifting rates. The continuous fascination for both poles has driven explorers, scientists, and tourists alike. As polar tourism rises, its impact on these ecosystems remains marginal, yet human actions at home indeed pose significant risks to their preservation. Captain James Cook set sail in 1768 in search of Terra Australis Incognita, a mystical southern landmass alluded to by ancient Greek philosophers. They believed in the existence of a southern landmass comparable to those in the northern hemisphere, arguing that Earth should maintain symmetry. However, Cook's discovery was vast ice expanses instead of the anticipated land. Consequently, the ancient Greeks were right about Earth's symmetry in ice, with both North and South Poles exhibiting impressive icy landscapes. But these geological siblings have distinct features. Antarctica envelopes the South Pole, situated about 850 miles inland, hidden beneath more than 10,000 feet of ice. In contrast, the North Pole dwells upon the Arctic Ocean waters approximately 450 miles from the nearest land, floating over a thin 10 to 20 foot sheet of frozen ocean water. Polar ice is an ever-changing marvel, yet the poles display unique shifting patterns. The South Pole's ice inches forward 30 to 40 feet annually, while its northern counterpart races miles ahead daily. Regardless of their contrasting peculiarities, both poles have lured explorers, adventurers, scientists, and tourists for centuries. Today's polar tourism offers a first-hand experience of Arctic and Antarctic wildlife, attracting tens of thousands to the icy realms each year. As tourism flourishes, the potential risks to the Arctic and Antarctic ecosystems cannot be ignored. However, the real threats lie far from the poles. Our actions at home have a more pressing impact on their preservation. The icy secret of Earth's climate. Have you ever considered how ice influences our world beyond a chilling addition to drinks or icy sports? Ice impacts our planet's climate by reflecting sunlight back into space, which helps regulate the Earth's temperature. This unique property, along with ice's capability to float without sinking, is vital in maintaining our environment. While the greenhouse effect is essential for sustaining life, human activities have tipped the balance with excessive carbon dioxide emissions, giving rise to potentially dangerous consequences for Earth's climate. Ice, the frozen form of water, holds the secret to our planet's climate regulation. Unlike most fluids, ice expands when it solidifies, giving it a lower density than water and enabling it to float on the surface without sinking. Apart from floating on water, ice has another critical property, reflectivity. If you've ever experienced a sunburn during a ski trip, you'll understand that ice efficiently reflects sunlight. This ability extends beyond our faces, directing the sun's energy back into space and creating a cooling effect. The polar ice caps play a crucial role in preventing the Earth from overheating by reflecting sunlight away from the poles. Thus, the melting of Arctic sea ice threatens to tip the balance by reducing this natural cooling mechanism. In addition to ice's reflective properties, our planet's survival depends on the greenhouse effect. With the Earth's atmosphere made up of 99% nitrogen and oxygen, the remaining 1% consisting of gases like carbon dioxide and methane is responsible for stopping heat from escaping. These gases enable a natural greenhouse effect that sustains our world in its current state. Without it, Earth would be nearly 60 degrees Fahrenheit colder with no traces of human life. However, the excessive burning of fossil fuels and the resulting release of massive amounts of carbon dioxide have led to a threatening shift in the climate balance, the anthropogenic greenhouse effect. This human-induced climate change is putting our entire planet's equilibrium at risk. Unraveling Ice Age Mysteries. Imagine standing amidst a 2-mile-thick layer of ice 20,000 years ago. That's precisely what most of Europe and North America were during our most recent ice age, which started around 120,000 years ago and spanned a century. Believe it or not, Earth has experienced as many as 20 ice ages within the past 3 million years. But how can we be so sure? The evidence lies in two unique places: the chemistry of sea shells and our planet's landscapes. When an ice age occurs, ocean water volume decreases as it becomes snow trapped in continental ice sheets. Consequently, the chemicals in the remaining ocean water become more concentrated, which are utilized by tiny marine creatures to form their shells. By examining the chemical composition of these shells, we can gather information about water levels and ice age conditions. Meanwhile, Earth's landscapes also serve as a testament to the effects of ice ages. Ice, being powerful enough to excavate, shift, break, and crush rocks, has shaped a significant portion of our planet's surface. The landscapes filled with rocks and boulders, the majestic Norwegian fjords, and the abundance of lakes in Scandinavia all stand as tangible examples of the transformative power of ice ages throughout history. Decoding climate change. Around 20,000 years ago, our planet began to warm up as the ice age ended. To confirm this, scientists investigate tree rings and polar ice layers, which reveal climate patterns from the past. By analyzing these rings and ice layers, experts have discovered that Earth's temperature increased after the ice age, only to cool by 2 degrees Fahrenheit by the 20th century. Thanks to advancements in thermometers, we have been able to monitor global temperature data since the 1850s, which shows increasing temperatures at an alarming rate. In 1988, the UN formed the International Panel on Climate Change, IPCC, to analyze and respond to this global warming crisis. Why does temperature matter? By examining tree rings, scientists have found that thick rings signify favorable growth conditions, while thin rings indicate droughts. Studying these patterns provides insight into Earth's historic climate. Similarly, investigating the layers of ice in our polar ice sheets uncovers valuable information about our climate history. Yearly snowfall amounts are compressed into distinct ice strata. A thicker layer means more significant snowfall, helping scientists deduce our planet's past temperature fluctuations. So, what does this reveal about today's climate? As the practice of recording daily temperatures became more widespread from the 1850s, the collected data indicates Earth is now warming at an accelerated rate, with temperatures rising by a worrying 1.8 degrees Fahrenheit in the last 150 years. Recognizing the gravity of this situation, the UN formed the IPCC in 1988, a group of international scientific experts tasked with evaluating and reporting on climate change research. In the 2007 IPCC report, the reality of global warming was deemed unequivocal, highlighting the urgent need for humanity to tackle this vital issue. Human impact on climate change. Earth's climate has always experienced natural fluctuations, but today's rapid global warming is majorly driven by human activities. Our drastic alterations to the environment include massive deforestation for housing, agriculture, and timber, particularly in countries like Brazil and Indonesia. When forests are cut and burned, the CO2 stored within them is released, contributing to the greenhouse effect. Our planet's burgeoning population of 7 billion people demands even more cleared forest lands to accommodate for their needs. Industrial activity fuels climate change even more, as the extraction and combustion of coal, oil, and natural gases started since the 18th century has considerably impacted global climate. Accordingly, the CO2 concentration witnessed a 22% increase between 1958 and 2009 due to fossil fuel emissions. Despite understanding the consequences of deforestation and fossil fuel use, we continue to rely on these damaging practices, driven by our need to support human productivity. Climate change, imminent impacts. Contrary to the belief that climate change is a distant threat, its consequences, such as melting glaciers, water shortages, and rising sea levels, are already affecting today's society. Melting glacial ice significantly impacts municipal systems and agriculture in regions near high mountains. A warmer world means less snow on mountaintops, leading to severe water shortages and potential international conflicts. Meanwhile, rising temperatures cause sea levels to increase, threatening the homes of 100 million people living close to the oceans, ultimately creating massive numbers of climate refugees in the near future. Climate mitigation opportunities. While stopping climate change is a monumental challenge, focusing on mitigation efforts is a more realistic and achievable goal. We can slow down the overloading of atmospheric greenhouse gases through energy efficiency and the use of alternative energy sources. These critical opportunities can help us sustain our planet and livelihood in the face of ever-worsening climate change. It's a tough pill to swallow, but completely preventing climate change is practically impossible. The massive amounts of greenhouse gases, like carbon dioxide, that already exist in the atmosphere are here to stay for centuries. This long-lasting residue is set to impact our environment even if emissions were to miraculously halt. Furthermore, our global economy relies heavily on fossil fuels. Their sudden disappearance would trigger economic devastation. So, with complete prevention off the table, what's the next best thing? Mitigating climate change. This approach targets slowing down and eventually reversing the overload of greenhouse gases permeating the atmosphere. It relies on enhancing energy efficiency in transportation, manufacturing, household appliances, and buildings. One straightforward measure is improving fuel efficiency in cars, something that contemporary hybrid technology already allows. Similarly, reducing vehicle weight through the use of lightweight materials could triple fuel efficiency. Additionally, there are countless alternative energy options that leave no carbon footprint. For example, solar energy captures sun rays on an industrial scale to generate electricity. Areas blessed with strong winds can harness the power of wind turbines to meet their electricity demands. Not to mention the possibilities of geothermal technology. By tapping into heat stored just 10 feet underground, homes can be efficiently heated and cooled. This subterranean climate control brings potential for widespread utilization. In summary, while climate change prevention is an uphill battle, climate mitigation embodies a realistic and valuable goal. By embracing energy efficiency initiatives and alternative energy sources, we open the door to a sustainable future for us and our planet.
As illustrated in HenryNPollack's A World Without Ice, the ice at the poles plays a critical role in maintaining Earth's climate balance. While climate change may be unavoidable due to existing quantities of greenhouse gases and reliance on fossil fuels, mitigation efforts can help slow down the process and minimize the detrimental impacts on ecosystems, agriculture, and human societies. By embracing energy efficiency measures, tapping into alternative energy sources, and gradually reducing greenhouse gas emissions, we can work towards creating a more sustainable future for our planet and ourselves. The time to act is now.